Let's start with it. Now, if you see here, wave, there are two types of wave. And can you tell me the names of those waves?
The longitudinal and transverse waves.
Longitudinal wave, longitudinal wave, and transverse wave. Okay, transverse wave. Now, let me ask you one of the fundamental question here again. Why do waves exist? What is the reason why they exist?
Due to some type of energy being transmitted.
Transferred, not
Yeah.
transmitted. There's a difference between transmit and transfer. What is the difference?
Transfer maybe it's direct contact and transmitted, isn't it? I know.
Some of the key terms you should be knowing very properly, because if you don't know that, you will end up using wrong key terms in the wrong place and you lose mark. What is the difference between transmitted and transferred? But they both are related to waves. That's why I'm asking you. If I say wave is transmitted, and if I say wave is transferred, what is...
Waves transmitted means from one place to another. It's like transmitted using free radios, I suppose.
Basically, there will be a starting point.
Yeah.
A radar transmits.
Okay.
Transfer is the actual path, the actual journey.
Okay.
Transfer, transmit.
Okay.
Transmit is the starting point, and transfer is as it goes forward.
Oh, okay.
Okay. So there are two types of waves: longitudinal wave, transverse wave. Okay. Humans only know these two types of wave. There is no other waves that we know of. The wave that we call sound is a longitudinal wave. The wave that we call light or electromagnetic wave is a transverse wave. So
Okay.
all the type of waves can be divided into these two broad categories. What about ocean waves, sea waves?
That's longitude? No.
No, sea waves are transverse waves.
Transverse. Okay.
What are S waves?
Huh?
S waves,
What is that?
earthquake.
Oh. Longitudinal?
Transverse.
Transverse?
What are P waves?
What is that, sir?
Earthquake.
Longitudinal?
They are longitudinal waves.
Okay.
From the epicenter, P wave transverse. They are
Oh.
longitudinal form, and when they reach surface, they become
Yes.
transverse in nature.
Okay.
Okay, so basically there are two types of wave, and all the other waves that you see in and around the universe can be broadly classified into these two, longitudinal and transverse wave. Now, first, let us understand the difference between them.
Yeah.
First, let us start with the transverse wave, which is a very famous and very easy to study type of wave.
Yeah.
What is a transverse wave? Tell me.
It's a wave that is horizontal and goes from one place to another.
Horizontal. That means longitudinal is transverse. Longitudinal is vertical. Okay. So you are meaning to say that this is a transverse wave.
Yeah.
And you're saying it's going horizontally.
Yeah.
So
Or
this
maybe
is
transverse wave has like a lesser frequency compared to longitudinal wave.
no, not at all.
Okay.
See, every wave has two things associated with it. One is the direction of vibration, other is direction of motion.
Okay.
Direction of motion is a direction where the whole wave is moving. And direction of vibration is the direction in which the particles are vibrating.
Okay.
Look at a transverse wave. If you look at a transverse wave, easily you will be able to identify that this is the direction of motion,
Yeah.
but this is the direction of vibration.
Vibration. Okay.
Vibration happens like this,
Okay.
but the direction of motion is like this.
Oh.
That's the difference. Okay, vibration happens like this, but the direction of motion is like this.
Yeah.
So a wave in which the direction of vibration and direction of motion is perpendicular to each other is transverse wave.
Okay.
So in simple, the definition is very simple. A wave in which the direction of motion and the direction of vibration are perpendicular to each other are known as the transverse wave. All right.
Yeah.
Then next thing that we will see is the longitudinal wave. Okay.
Yeah.
Longitudinal wave. Talking about the longitudinal wave, first I'll tell you the definition of longitudinal wave, then only we will be able to connect it. The definition of longitudinal wave is it is a wave which is the direction of motion and the direction of vibration are perpendicular, either like this or like this. Direction of vibration is like this, not perpendicular, same
Parallel.
direction, parallel.
Okay.
So if the object is moving like this, the object will be vibrating like this.
Oh.
These categories of waves are coming under longitudinal wave.
Oh.
One of the famous longitudinal wave is the sound itself. Okay. So you have a transverse wave, which is light wave. For the famous transverse wave is a light wave.
Yeah.
Then you have a longitudinal wave, and one of the famous longitudinal wave is the sound wave. And we are going to see about both of them in this chapter.
Okay.
All right. Now, let's talk about this wave's transfer behavior. It can be transmitted from anywhere. So when I talk about transmitting a transverse wave, light comes from a source, light source, right?
Yeah.
Sea wave, which is transverse, comes from a disturbance of the ocean.
Yeah.
And even a string, you see in a string, if you move it like this, you see transverse waves on the string.
Yeah.
Even that is because of the motion of your hands. So these are the places where it is transmitted.
Okay.
And it travels through a medium. Now you see medium.
Yeah.
Medium is something which is very much important for a wave. Medium. Because transmitting can happen anywhere.
Yeah.
But transfer happens in a medium. Let's talk about sound. Even in sound, there is a source of sound. Like if I clap my hand, that's a source. And from there, the sound is transmitted. And it reaches your ears through a medium. Yes?
What's that?
Through a medium.
Yeah.
So you require a medium then, right?
Yeah.
All right. Now, let me tell you what role this medium plays for a wave. Most of the wave, apart from one wave, all the other wave require a medium to travel. And it's only electromagnetic wave which does not require a medium to travel.
Yeah.
It is a special built of an electromagnetic wave, which is kind of made up of electric field and magnetic field. And that is the reason why it does not require a field, that it does not require a medium to go through anything. But all the other waves, sound, ocean wave, string wave, all the other waves require a medium to be seen.
Okay.
All right. So medium plays a very important role for a wave because medium can decide how much fast a wave can travel. What is the speed of light? Do you know?
3 point something times 10 to the power of 6, I think,
8. 3
8
into 10 power 8 meter per second.
per second. Yeah.
Okay. Now you see here, speed of light. The light travels fastest in vacuum. So we will be discussing more about this when you go to electromagnetic wave. Okay.
Yeah.
So the light travels fastest in vacuum, but when it enters other medium, it becomes slow.
Yeah.
That means in water also it becomes slow. In glass also it becomes slow.
And where?
Glass.
Yeah.
A transparent medium. Okay, so you see when the light wave enters another medium, it technically becomes slow. So that's what I told you. A medium decides the speed of the wave traveling in it. But for sound, it is the opposite way. Sound requires a medium. It cannot travel in vacuum.
Yeah.
Sound cannot travel in vacuum. It 100% requires a medium. But there is something about sound wave which makes it faster in solid, slowest in air.
Yeah.
But for light, fastest in air, slowest in solid.
Got it. Yeah.
Okay.
Yeah.
It is the built of the waves, which we will see separately when we study sound and electromagnetic wave. How are they built, which makes them fast here and there? So the medium decides the speed of the wave in that particular medium. Okay. And it depends on what type of wave it is and how it transfers energy. That is the thing which decides the speed of the wave in the medium also. Okay.
Okay.
All right. So did you understand the two types of waves in detail?
Yes, sir.
All right. Now I have to show you the longitudinal waves image also right here. I would show you this image. For that, I will be taking the help of Google and I will show you one image of a longitudinal wave. I will just show you 1 second. Longitudinal wave, GIF. What is the meaning of GIF?
Give like I don't know the full form. It's like a
And
moving.
yeah, it's a moving pictures that would be required right now. You can observe a picture here, which is actually not moving as of now. But now, can you see it's moving?
Yeah.
Now, there is something that has to be seen here. What you're seeing is a longitudinal wave. Okay. Look at the second wave very carefully. So can you, do you know where they're getting transmitted from?
What's it?
Where is wave getting transmitted from? Can you tell me? Transmission.
Means it's where it's getting transmitted from.
That means the starting point, the origin of the wave.
From like the left hand side?
Yeah, what is that?
Some kind of compressing thing. Piston?
Yeah, but can I associate with a vibration? This is
Oh,
vibration,
shape.
right? This is
What's
vibration, right? My
yeah.
moving hand is a vibration, right?
Yeah.
So can I say it's one part of the vibration that is happening there?
Yeah.
And can you see when the vibration is happening, there is a region which is very much close by, and there's a region where particles are very far apart.
Yeah. Yeah.
Two regions are getting formed,
Yeah.
and what you are seeing traveling is a longitudinal wave that is traveling.
Okay.
Longitudinal waves have two special regions. Of course, we will be seeing more about this in the sound chapter. Okay. Yeah, we will be going to sound chapter. I think after this we will start sound, but I would not like to start sound right now because as I told you, I want to go for practice. Okay, but I will just tell you what are these things. Okay, now but now look down image. You see particle and wave.
Yeah.
Is a particle moving away?
Yeah, it looks like it's moving the opposite side.
No, no.
What is it?
Look at the wave and look at the particle and how is their motion. Can you tell me in your own words what you are seeing right now? The wave is traveling like dash. The wave, okay, just tell me in your own words how the wave is traveling, how the particle is traveling.
The particle is just vibrating
Very
as the wave is
good.
going from one place to another, left to right.
Very good. The particle is just vibrating, that's all.
Hmm.
But the wave is actually moving out.
Yeah.
So this is a nature's best synchronization. You know what synchrony?
Yeah, like two things happening at once.
Yeah.
Many things.
So here the nature's synchronization, you can see that particles are actually not moving. They
Hmm.
are just vibrating. But the collections of particles vibrating like this creates a synchrony where it appears as if a whole wave is moving.
Hmm. I don't
That
know.
is,
I still
yeah.
can't visualize how that works.
Yes, you are seeing it in front of you. The sound itself it travels like that. That's why this is one of the nature's beauty.
Yeah.
Transverse wave is also nature's beauty only. So that's why wave. That's why there's a separate topic called wave. People study wave in detail
Yeah.
because wave is one of the wonder of nature. It's a synchrony which can never go wrong. Just imagine if one particle does not obey, so whole it's going to disturb the whole wave. Do you know that? If
Yeah.
one particle says that I don't want to move this way, I want to move this way, it's going to disturb the whole wave and it's technically going to the whole wave will die. But
Oh,
look at the synchrony, how the all the particles are vibrating in such a way that it appears as if the whole wave is moving.
yeah.
That's a longitudinal wave.
But the wave is moving.
The wave is moving, but the particles are not moving.
Oh,
Now I'm going to ask you one more question. You have to answer me this. The wave is moving, but particle is not moving. So wave is moving for some purpose. What is the purpose?
to transfer energy.
Yes, the wave is basically carrying the energy,
Yeah.
and the medium is just facilitating it. Particle is a part of a medium, not a part of a wave, remember?
Oh, okay. Okay.
Understood?
Yeah.
Wave is moving through a medium. Particles are not moving. Particles are the part of a medium, and particles are only facilitators of waves. They
Okay.
are not the actual wave,
Okay. So the energy,
is the wave.
like the wave moving, makes the particle vibrate.
The energy
Energy
is
from the wave.
the energy is the wave.
Okay. Yeah.
Okay. The energy is the wave which is moving through particles.
Okay.
Particles are not the wave, particles are not the energy.
Okay. Yeah.
Now, is that concept clear to you?
Yeah.
So same thing happens with the transverse wave. So now let us just look into longitudinal wave in detail. Same thing happens with the transverse wave too. So I will just tell you about transverse wave. Oh, sorry, longitudinal wave, little bit more is there. Now you saw the particle and wave behavior. Now there are different parts, regions. Can you see? There's a region where the particles are very compressed, and there's a region where the particles are far apart, and they are also moving.
Yeah.
The region where particles are compressed together is known as compression.
Compression.
The region where the particles are far apart is known as rarefaction. Rarefaction, not refraction.
Rarefaction.
Rarefaction. So many people gets confused. Many of the seventh graders, where we introduced in seventh grade here in IGCSE, we introduced. I remember that we used to introduce reflection and
Yeah.
refraction.
Yeah.
There, when they come to higher grades, we introduce sound wave, rarefaction, and compression. Many people, half of the people in the examination write rarefaction as refraction.
Uh,
Both are the part of waves, so they get confused, and they are the part of the waves, and they study in the same unit where they study sound also, where they study refraction also. So everything comes together and they write it as refraction, and they keep losing marks.
uh,
That's why it's called rarefaction.
yeah.
Compression, rarefaction.
Rarefaction.
Okay, so these are the two regions of longitudinal wave.
Yeah.
Now let me take you to a transverse wave. Okay, now this transverse wave which I'm talking is not light.
What?
Let's say water wave,
What?
transverse wave. Okay,
Mm.
light is a totally different wave, but still it's a transverse wave. But showing you the example of light will not be a good thing here. So transverse wave, GIF. You're able to see, right, what I'm doing here?
Yeah.
I hope this GIF works. Yeah, it works. Now, yeah, can you see here?
Yeah, I can see it.
Are the particles moving?
Mm. No, they're not.
What are they doing?
They're like just moving up and down, like
Vibrating, right?
vibrate.
Which is perpendicular to the motion, direction of motion,
Yeah.
like this. Motion is like this,
Yeah.
vibration is up and down. That is what is the definition also,
Yeah.
right? That is the definition of transverse wave, right?
Yeah.
The direction of vibration and the direction of motion, both are perpendicular.
Yeah.
Okay, now this is what you have to observe here, but the wave is moving, right?
Yeah.
The wave appears to move just like a longitudinal wave here also. The wave is appearing to move forward.
Yeah.
Now I will tell you the parts of the wave. So I would say the top part, can you see it's known as, do you know what's the name?
Crest.
Crest. And the bottommost part is known as?
Throw.
Oh, that's all. Okay. Now there is something called wavelength and all those things that we will go in the next class.
Amplitude.
Amplitude, wavelength, frequency, time period, all those things, the characteristic part you will be so see in the next class.
Okay.
All right. So I hope you have got a good understanding of two types of waves.
Yeah.